reality. Next up, we're just going to move really quickly right along into our next panel. This is on VR input. On this panel, we have Richard Marks from Sony, Danny Woodall from Sixense, Tristan Dye from Noitom, who does the perception neuron, Oliver Kreylos, Doc Ock, as some of you may know them from UC Davis, Yasser Malika from Valve, and moderators Jason Jerald. So we're going to bring our guests up on the stage, and they're going to have a riveting conversation about VR input. Where's it going? What is it doing? And always count on Jason for some great, juicy questions. So let's give a warm round of applause as our wonderful panelists make their way up. Let's do it.
Sure. I need one more chair.
Okay. Probably here. Thank you. Bring back the clicker.
Okay, thanks. Good.
Does that look like a clicker?
Yep. Green arrow. This one, that one. Yeah.
There we go. Okay, let me go back. Okay, welcome guys. Welcome to the VR input panel, and it's very bright up here. Today we have some world-leading experts, the best of the best as far as exploring what to do with virtual reality input, not only on the hardware side, but also the interaction side. Now, before we get started, I want to ask, who here likes, does anyone here like free stuff? Okay, so we're going to be giving away something. All of those that, anyone have hear of something called Twitter? A few of you? Okay, the person that tweets something about the panel, what one of our panelists has to say, that you tweet something very insightful, then go ahead and include me on that tweet, and at the end of the talk, we'll give away a book, to a VR book, to the person that has the most insightful tweet. And so here's the book here. This is my book, the VR book, and it talks about, what part of it talks about input. So very appropriate for this panel, and there's my handle up there. You can go ahead and tweet to that when you hear one of our panelists say something great. Okay, so we'll go ahead and get started. We have 5 panelists, as you can tell. And up first, we have the legendary Richard Marks. And he has not only worked with Project Morpheus, but he's been doing VR type input for, what, 15 years now or so? For a long time. He has his PhD in robotics from Stanford. And he is the guy that is basically behind the PlayStation Move. And so he certainly knows about input, and of course he's been very heavily involved with the Project Morpheus. And we talk about how VR has not shipped yet. Well, Richard has shipped over 20 million units of the PlayStation Move, right? So he's definitely someone to listen to. So with that, I'll hand it off to Richard.
Thanks, Jason. So as you mentioned, I'm currently working on Project Morpheus, and we're really looking at a lot of different interaction techniques. You hear the word presence mentioned a lot, and for me, I think of these different layers of presence. Start with just having a good image when you put your eyes in there. Then, of course, the next layer is you look around and you expect things to change in a realistic way, the way they do in the real world. But then after that, you get to the more interaction layers where you look down, you expect to see your hands or your feet in VR. And then when you do something, you expect the world to change in a way that makes sense. And that's where really the input side of VR, I think, takes over. And we've been looking at a lot of different techniques. One of the really interesting ways, I think, to break them down is from abstract to literal. So abstract, maybe the most, would be something like a keyboard where you press a button and some action occurs. And a very literal interface would be something like a treadmill where you walk and you expect to move through the world at a walking pace. But in between, there are a lot of different kinds of layers of abstraction. And you have the traditional game controller, which is fairly abstract, but then you could add some tracking to that and it becomes a little bit more literal. And then like the PlayStation Move is somewhere in between there where you have this very literal motion that you can do, but then the buttons give you an abstraction of grabbing or shooting or something like that. And then you have hand tracking. We've been looking at that too. So there's all these different kinds of ways you could do input. And I think really depending on the experience you're trying to enable, it depends on which one you would choose. I'll turn it.
Okay, well, thank you, Richard. Up next, many of you probably know from reading his blog, very insightful and very detailed on his blog. He's not just speculating, right? He provides a lot of details on implementing head-mounted displays and playing with different types of input over a wide range of virtual reality beyond head-mounted displays. They are very different forms of virtual reality. And this is Oliver Kreylos. Some of you know from his blogs and such. He's an associate researcher at University of California, Davis. And go ahead, Oliver.
Right, so I guess I'm again the odd dog out here in that I'm not a hardware manufacturer. I don't make input devices. I'm on the software side, and I'm essentially have to clean up after these guys mess it all up for us. So the basic idea is that... Oh.
I got a little bit of hit, sorry.
Oh, no worries. I mean, I don't have a slide anyway. So the basic idea is that if you have this jungle of input devices that we have right now, it's represented with the PlayStation Move and Sixense and Lighthouse and Perception Neuron, and you have the Prio VRs and what have you. How do you actually write software that works with all of these without having specifically for each device? And if you think about it, sort of the situation on the desktop is very different, which is why not too many people on that end think about it. You have the mouse, and then there are maybe 100 different manufacturers of mice. But essentially, the mice are all the same. One might have 3 buttons, one might have 4 buttons, but you know, they all work the same. But in VR, you have things like you might still be using a mouse. You might have a joystick. You might have a steering wheel. You might have a 6-DoF tracked input device like the stem. You might have a full skeleton tracker like Perception Neuron or Prio VR. So how do you abstract between all of these? And a bunch of approaches right now, like the OSVR approach or some of the Sixense SDK approach, and we don't have them here anyway. So the idea there is to abstract on the level of the input device, that you say, okay, we have a unified skeleton that we get, and the skeleton is being fed by optical tracking or by magnetic tracking, whatever. But I think that actually the abstraction should happen at a much higher semantic level, where instead of saying, oh, the user pressed button 1 at position XYZ, what you should actually do is that the program here said, oh, the user wants to do an event. The user wants to change, say, the background color to red. And then how that is mapped to a device depends on the device. So in a mouse, you would have a usual menu. You select red. And in a 6D-off device like a stem, you would just have a 3D menu maybe where you select from something, or you have a bunch of icons. And if you have a hand tracker, like the Leap Motion, that's the name, then you would have a hand menu where you pop up and select. So these are all different things. And if you have a brain plug, you would just think about the color red. So that's the idea there. This sounds like a crazy idea, but it actually works. We've been doing this for about 17 years or so. And it works great. You can write a software once, and it works on the desktop. It works on the cave. It works in a head-mounted display. And so now the question is, where can we take it from there? Can you apply this also to games? Because I do scientific software, but my hunch is, yes, we can do it, but I haven't done it yet, so this is where the discussion as a community comes in.
All right. Thank you, Oliver. Up next, we have, many of you know from Sixense Entertainment, Danny Woodall. And Danny is a designer, but he also has a background in mechanical engineering. He definitely knows what he's talking about. A lot of you have probably tried, if not all of you, have tried his work with the Tuscany demo, where you can actually go in and interact and pick up objects within the world. And also, you definitely, if you haven't tried it yet, the lightsaber demo out at the Sixense booth. Danny?
Yes, so thank you. One of the roles there I play is on the software side. So we do, obviously we make hardware, and I'll have to correct Oliver that none of you probably do have a stem yet, but hopefully that changes very soon. But I come, obviously I have an influence on what we do with hardware, but I also have a different perspective where I'm looking at it from an end user and the kind of tools that we're going to provide to people, the kind of experiences we're going to give you to have you understand why input is so important in VR. And so as we progress, with our VR SDK implementation and just our core API, I'm always thinking about, okay, well, how can we make this easier for someone, say, who doesn't have programming experience? How are they going to come in here and try to use our system when they're just an artist or a designer without these types of skills that typically you need to have to kind of wire up a bunch of data to have actions happen inside of this game engine? So we've been doing a lot of, a lot of the tools, especially like Unreal and stuff, are becoming much more powerful, and you have a lot of node-based things. So it's very easy now to start becoming, more productive without having to be, having these skill sets that are required typically in the past. And we're doing the similar things in Unity. So someone, that has, a character can just bring it right into the scene and drop it in there and pull a couple transforms around, and now that character can have this full body presence, which we look down and you see yourself, and you see, all your actions are mimicked. So again, this is super powerful because a lot of times these guys have great ideas, but are handcuffed to someone that's going to help them enable that type of vision. So yeah, that's pretty much what I do there.
Thanks, Danny. Okay, up next we have Yasser Malaka from Valve, and previously he did a lot of work also with Google SketchUp, right? He was responsible for a lot of that I'm sure a lot of you have used. At Valve, he worked on several games. He worked on the Half-Life, Left 4 Dead series, and also Portal. And he tells me his background is architecture, so he's really interested in mixing the virtual and the physical spaces. Yasser?
Thank you. Yeah, so input has always been conceptualized as an important part of VR. And a couple years ago when we started giving the room demo, it became very clear right away when we were able to create a strong sense of physical presence that it almost kind of creates a promise or a contract for the user to, you can reach out and touch these visuals. And while the system at first didn't really provide a way for us to explore that, subsequent experiments where we use different tracking systems allowed us to start to play with that. And we learned several things. From one set of experiments, we learned that low distortion, low latency, and also the same precision and accuracy characteristics that worked so well in the HMD were very compelling in the hand as well. And then from another set of experiments where we did actually put a second camera in users' hands and connected it through a second PC and then networked them, although it was not practical, that gave us a sense of what a full range of motion could be like. And then a third set of experiments connecting our tracking to the Steam controller gave us a sense of how rich even a small sense of precise haptic touch could be. And that means we could do things like hinting and even suggesting a sense of friction or momentum to interactions, not just through the fingers, but through the wrists, through the elbows and shoulders. And it should come as no surprise. This diagram, actually the previous diagram, shows the homunculus, which is the mapping of the neocortex. And you can see that hands and fingers represent a large proportion compared to other parts of the body. So, all those things kind of drove us to kind of choose that direction to go, and combined with the fact that if we look at the next slide, a lot of our developers felt that it was very important that we have a consistent input solution right in the box with the HMD. So Lighthouse really gave us a path to provide that solution. And this is our first Lighthouse track device. It's a small puck. It's essentially the tracking subsystem of an HMD that has been shrunk down into the palm of your hand. And we attached that to the Steam controller, which provided the haptic feedback. And the device on the right is our latest iteration, which is wireless and battery powered. And that getting it wireless was kind of the last key to providing that full presence. And so we feel that that although object in the hand isn't kind of the definitive place where VR input lives exclusively, we think it's an important first step, and we think that it can enable a lot of rich, compelling gameplay and applications, non-game applications in the short term, and that it will be not mutually exclusive with other forms of input.
All right, thank you, Yasser. And up next, we have Tristan Dye, who is a co-founder and CTO of Noitom, and also he helped create Perception Neuron, which is out on the exhibit floor as well. And he's got a number of degrees, including a PhD in automation and robotics, and he's really, his entire career, he's been focusing on motion capture. So he's definitely in the right place of applying this to virtual reality. And Tristan.
Thank you. So I actually took a 15 hours flight yesterday from Beijing to here, and this morning Jason emailed me say, hey guy, you have like 5 minutes to do presentation, so I will use my like 5 minutes wisely. First of all, why I'm here talking about input. We are actually the #1 inertial sensor-based motion capture supplier all over the world, and previously the majority of our clients are doing like filmmaking, animation making. But starting from last year, surprisingly, we found that 33% of our clients are from game interaction and gaming. So that's a very, very big change from like, I don't know, 1-2% to 33%. That's a very big change for our company. So next slide, please. So what we do is actually we build a motion capture system for game interaction, not only for the hand motion capture, but also for full body motion capture. It's okay, just continue. Just continue, it's okay. It's okay. Oh, okay. So there are a lot of input devices out there already, including us, doing like hand motion interaction or a joystick or some kind of full body motion capture like us. So what I think for all of those input devices, they can be categorized into like 2 categories. Next slide, please. So we are talking about something using some external reference point and something strapped down, wearable on your body. So there are very good advantages by using some external reference, which is absolute positioning and very, very high accuracy. We are talking about in millimeters. And by using the sensors, I mean the wearable sensors, you don't have to stay in a studio, you don't have to stay in a certain room, you can walk around, you can jump around, you can go for like 100 meters away, but you have drifting problem, you have like accumulated error. So that is the majority of the problem we are facing to right now. So what I think in the future, when I say in the future, I'm not talking about like 10 years ago or like 15 years ago, I'm talking about in 2 years. Probably we are looking to something hybrid. So next slide, please. Because if we can make some kind of hybrid system that make the use of the goodies from optical system or like magnetic system like STEM, which is like absolute positioning and high accuracy, and we can make use of the goodies from the wearable system like the sensor-based motion capture system, then probably we can have like an ultimate solution to the commercial level input device for virtual reality. At the very beginning, next slide please. At the very beginning, probably we need to rely on a very heavy wearable system because the algorithm, the hardware is not good enough. But sooner or later, we will try to minimize the sensor and the number of sensors we need to put on your body, on your hand, and try to reduce the number of sensors you need to use for this kind of hybrid system. Next slide, please. So something like this, I think, could be the ultimate solution for input, a hybrid but very light system on your body. Thank you. Thanks. That's all.
Okay, thank you, Tristan. We'll now move on to a few questions. And Tristan, that actually leads great into the next point that I'd like to make, is here I kind of organize some different types of tracking technology, of input technology, and the different advantages or what each is capable of. And as you can see up there, we have the different capabilities, right? Do you have that sense of proprioception, which is where your body is located, right? A physical controller has that, and a full motion capture system has that, where a handheld controller that doesn't have tracking does not provide that extra sense. It's not realistic. And the point here is that none of these types of tracking technologies has the advantages of everything, right? It very much depends on what you're trying to do with your project. However, that leads into the great point that Tristan made of what can we do to combine different input technology together to create hybrid systems. And then we start gaining the advantages of multiple types of devices. And Richard has also done some work with that. Danny has, Sixense has, as far as integrating different technologies together. So it's definitely moving in that direction, and that's where we need to move to get really high quality input. And so my question is, what, for each of you personally, what is your favorite method of types of input, and why? Why do you think that your technology, or a technology that you really appreciate, why do you like interacting in that way versus some other way? And if you could expand maybe on the sensor fusion that Tristan mentioned as well, that'd be very interesting. Anyone want to start?
You made a great point that a huge amount of the brain is devoted to what you're doing, for example, with your hands. And there's a quote, or in a book by Isaac Asimov, he talks about the ultimate interface to a computer should be through the hands, actually, not through the brain. And I think that's interesting because people do, that's one of the big differences between humans and other things, is how much you use your hands versus, you know, other parts of your body. And I think, you know, already a lot of the interfaces we do now are through the hands, so it makes sense that we want to keep that kind of capability and then add new capability. So I really think that, you know, what you guys are doing with hand tracking, what I mean, everyone has been looking at doing something with hand tracking, so I think that's kind of a no-brainer, but that's still, I think, the most powerful right now.
Yeah, I mean, I think I would agree because all the experiences that we've seen and experienced ourselves, like the first thing you do in VR when you feel like you're really there is you reach out and look for your hand, you know, and if you have a device that tracks your hand, it's like magic just happened. If you don't, you have to expect that, you have to think about in your head, why didn't that happen? And so, and we started noticing too that with the other systems out there that weren't doing that absolute tracking, that when you get to, you know, if you have to think about how that endpoint gets to where you're trying to get it to go, that, you know, sort of breaks this, you know, sense that you have control over your hand in the virtual world. In the sense of kind of getting back to what Tristan was saying with the hybrid solution, I think, you know, something combining what he's got with the stem would be very entertaining because I can give you this absolute position right here and here and perfect. And then, you know, we don't really care much about what the elbow's doing. It does become more important once you get like a social element in there and I throw you and you're watching me do it. So if I'm playing the lightsaber demo, I can do everything I want and block all the bolts and it looks great and feels great from my perspective. But from the third person perspective, it's not quite as compelling or as realistic, maybe because my elbows might be tucked in a little bit or, you know, they're doing something a little bit off because we don't have enough data points for all this. Again, something like with Lighthouse, you know, they have this awesome tracking with big volume and, you know, having something like hands or even fingers from like our type of solution. Now you have a real localized electromagnetic solution, which is where we shine. And so combining those types of technologies together, I think would, again, be this really hybrid solution that capitalizes on all the best that each of these technologies have.
I'd especially be interested in hearing from Oliver because I know you've done some great work with vision and other types of tracking.
The end, but yes, I can jump in right here. So I'm looking at it from a user's perspective, and of course it is very application dependent. You want to use different input, whether you're driving a race car down a track or flying a spaceship or actually doing things like modeling in VR, measuring things. That's what I'm doing, so that's where I'm coming from. My favorite input device type, I would say if I have to categorize it, is a globally accurate 6 degree of freedom tracked handheld thing. Because we have been using it for the longest time in various incarnations, starting with Polhemus Fast Track to now using our intersenses or stems or lighthouses or PlayStation Move, what have you. And the nice thing about them is you can create interfaces that are extremely intuitive. We have brought probably about 1,000 people or so over the last 10 years to our big VR environment. And every single person that comes in, I give them the controller the first thing, and I tell them, okay, pick up that thing you see there and then look at it and move it around, and everybody can do that. And then it takes off from there. So we have been putting this paradigm really into the foundation of what we're doing in terms of the software and also in terms of the approaches, and it works out really well. And I'm kicking myself now. I could have asked you to show the video that I have that I'd like to bring up at this point. I forgot, doesn't matter. You can go to YouTube and figure it out. But so that is really a wonderful input device paradigm that I like, where you can just do things. You grab this object and you put it over here and you connect these two together and you build something in VR. It's very effective, and it actually turns out we can prove it, that you can build things about 10 to 15 times faster than doing it on the desktop, which is a pretty big deal, I think. So now to look at a concrete thing, my absolute favorite input device of all time was the fake space pinch glove, which was a data glove that was totally trivial. It had just contact pads and edge fingers, so you could have 1, 2, 3, 4 button presses, and it was globally tracked using back then a Polhemus fast track. Doesn't matter what you do. So with that thing, it was just great. You could just, without thinking about it, grab things everywhere and just pick them up and move them around. And the thing is that with good enough accuracy, like provided by Lighthouse, all these technologies here, you don't have to look for what you're doing. Your muscle memory takes over. You don't have to think, oh, I need to get the mouse cursor onto that thing, and then I can grab it. You can just grab it and do it. You can juggle in VR. I saw this video the other day where somebody was juggling with the Lighthouse, and everybody was like going gaga, and I thought, well, yeah, of course you can do that. You've been doing it for a long time. So that's my favorite, really, and the paradigms that come out of it. But then, of course, if you don't have that, you still need to make it work, and that's where the larger infrastructure comes in of trying to do it abstractly. But if I were to pick a device, that would be it.
Anyone else?
Actually, in my point of view, the best input method should be something you don't have to learn. So I still remember the first time my 4-year-old nephew tried to use iPad. He literally spent like, I don't know, 5 minutes to learn how to use iPad. So that is a very good input method. So that is say, probably it's not very good to mimic the 2D interaction, I mean, in virtual reality. The reason why we think a menu, a drop list, click, double tap is good because we already have the experience of using a PC. But in the future, probably our clients or our users don't have that kind of experience. So it must be something that you will naturally do in the virtual world. And that is the reason why we put a lot of effort to explore how to use your natural motion, your hand motion, your body motion to do interaction with the computer. Yeah.
All right, well that brings up a great point, that what do you do when you get that input, right? The input device is only part of the problem. Now whatever you do to make something interesting, you have to go beyond just reading the data. And so this next slide, I've divided different sorts of interaction patterns consisting of 5 types of interactions. And so for an example, you can see in the middle there, viewpoint control is a walking pattern. Now, a walking pattern might consist of, there's different ways to do walking pattern. That's just kind of a general pattern that can be implemented in very specific ways. So it might be something of walking in the real world if you have a wide area tracking system. Or it might be a walking in place or a treadmill. But the basic concept of walking is there. Or you might have a hand selection, which is very straightforward. Kind of the first thing you do is you reach out to the world, intersect an object, then push a button or close the hand of a glove, for example, and then you're able to pick up that item. But you can go beyond that. If you want to do something realistic, it should be in your personal space, but you can start adding things on top of that. For example, what happens if I have sort of an Inspector Gadget type of hand where I can reach beyond personal space, right? You can start doing interesting things that are not limited by reality. And so the next question is, what sort of, as far as kind of an extension to the last question, of what are some really interesting techniques that you've found that you've been able to either create yourself or great examples of kind of going beyond the obvious interactions?
Haptics, haptic feedback, that is always something people are looking for. So sometimes I even challenge myself whether we should go with like do the motion capture without wearing anything, or like what we're doing, we're wearing like sensors. Why we're wearing sensors? First of all, we have the accuracy, we don't have the occlusion issue. You don't have to put your hand in the line of sight. But the next thing, maybe if you're wearing something, there are always some method that you can make some haptic feedback. I think haptic feedback will always be something we're looking for.
I agree that that's a very strong, strong addition, especially because when you can virtualize it, it's really interesting in VR because the affordances of the space and of the devices that you're holding can all of a sudden be context sensitive in a way that they can't in physical space. And by layering haptic feedback on top of that, you can do very interesting things. As you said, interacting in your immediate physical space, you tend to be able to manipulate things directly very well. But then after it gets out of your arm's reach, now it kind of compels the user to step forward. But in VR, it's very easy to then transition from instead of like a direct one-to-one manipulation to kind of more of a laser pointer where now all of a sudden you're kind of extending the distance, and it almost becomes like a spectrum of how you tune those different interactions, and that affects how a user holds the device, and it also affects the accuracy and the precision requirements. Because now all of a sudden, if you're pointing at something very far away, and you're tuning it to haptics, and but it's shaking a whole bunch, you have to kind of account for that, and having a hybrid approach with IMUs can really help kind of bring that full range of interactive agency to an experience.
I think one thing I'd like to add is that what we found, we were working with a company at the time, they were Striker VR, I think they're Deca Technologies now, and they do some really realistic weapon simulation, recoil simulation, and so they came to us because they didn't have any tracking, and we used our system to track this physical gun in the 3D space. And then we brought it into one of our demos pretty quickly because it's all, just kind of drag and drop. All we needed was the model. So we had a gun that would mimic the similar proportions of this gun. And within like 15 minutes, my engineer down there had it working. And just having that real simulation of the recoiling weapon and holding it as you really would was, I guess looking back on it now, I should have thought of how cool that would have been, but I didn't really think that this was going to be so amazing, because you can literally hold this thing and look at it like you're really holding a weapon. And so you can convince yourself pretty quickly that this object that you're holding is real, and seeing it do these real things in the real world is super compelling. Same thing we did with the lightsaber demo when we made it. I actually bought a toy lightsaber handle and just slapped a stem pack on it, and it felt so cool to actually hold this thing that really felt like the thing I was holding in VR. So that might be the simple first iteration into good haptics in VR, is you really use these physical environments you could have. People are making these stages that mimic the real virtual world physically, so they can go out there and touch the walls and everything like that. I think I did a demo like that where you told me to turn the light switch off, and I walked over there, and it was a physical thing that I really did. There was no input in VR, but it worked, and I had to ask him, I'm like, did I? Oh, he's like, no, I got a button over here, Yeah.
Don't look at the man behind me.
That's right. So I think that's definitely super compelling. And now with all this stuff that we've been doing even with audio, I think like having the right audio in there too, just sort of, even though it's not really input, it just adds to this sort of feeling like you're really there, because everything is just working the way it's supposed to. Once you get that and you start to and you take that away, and then it's kind of in your face the next time you get into VR when the audio sounds off, and things like that. So.
Actually, haptics is actually an output. It's not an input, right, for VR.
That's right.
But haptics is the very, very close friend of input device, because probably you need to add that output onto the input device to get the first, your touch, feeling of touch.
Part of the feedback loop.
Yeah.
Hand-eye coordination.
So although it is like an output phenomenon or output thing, but you are not putting that on your display, but it's like an accessory to the input.
But one of the things that makes haptics much more powerful is when you have spatial tracking, so you know when to trigger the haptics based on where you are. If you don't have that, then haptics becomes a lot more like a vibration that is a
Yeah, it's like the rumble versus the one-to-one. That's one thing we found very compelling, is that as the user accelerates with their hand, when the frequency of the haptics matches it, it creates a sense of mass to the air almost.
Yeah, they're using like vibration frequency to cheat you, that make you feel like some weight there, right?
And also other things like we were interested that some of our developers use the haptics to bring the user's attention to their hands, and even when they were outside of the field of view of the HMD, and that was a surprisingly effective method of
getting someone to look at their controller.
Yeah, absolutely.
Yeah.
One of the strongest interactive things I think I've ever done is, and it's really powerful, is if you have an object in a hand, you can look at it and look around at it, and you can move it very quickly, like you do in the real world. And then you can use the other hand to then do something. So you have one that's kind of controlling the look at, and the other one that's controlling the action. And that's a very natural way that people do things. If you try to like move your head all the time to touch something or to act on something, it's a lot harder than if you have it in your hand. So two-handed manipulation, I think, is really a great interactive experience.
I know, Oliver, you've done some work with two-handed interfaces.
Yeah, Jason, I'm looking at your interaction patterns thing, and it's funny because it almost 100% matches with the class hierarchy and our interaction tools that we have in our software framework. And so to take a little detour here, one of the basic ideas of our stuff is that one of the things we found out over a long time is that there is no one-size-fits-all for interaction. It is not only dependent on what kind of input device you have, it's also dependent on the kind of task at hand and on personal preference. Some people like this way of doing it, other people like the other way of doing it. So what we ended up doing is just implement them all and then make it possible to select them dynamically while the program is running. So one user might like to do things a certain way, and another user might like to do things another way, and they can just do it by changing the way the functions are mapped. You have a right-handed user, you have a left-handed user. And so you mentioned earlier how you extend your physical reach, how you have an inspector gadget, tool like a laser pointer. And one thing that we found that works really well is you just break all these things apart, you smash them with a big sledgehammer, and then you put them back together in the Lego approach, we call it. Well, I just made that up. So for example, you make one tool, we call them tools, that allows you to pick up an object that you're directly touching and then just move it around like you described, because it's extremely powerful of doing that. And then you have another tool that is totally independent, which just shoots a ray from your input device and positions a virtual input device at whatever position that ray intersects a world object. And so now you have these two independent things, and you mix them together, and you have the laser pointer selection, where you point at something, select, and then move it around. And you can do this with all these different tools and stack them in weird ways, and it works really well. And since you mentioned two-handed interaction, that's actually one very funny thing which comes out naturally out of this update, out of the setup where you have a dynamic creation. We have that program that I like, which is a molecular dynamics program. It's my favorite benchmark for how good a VR environment is, how long it takes you to build a certain structure. And usually we use it in our system with one handheld input device. And so I have caught myself countless times just grabbing something, and I want to make this connected, so I use my other hand and trying to grab this other thing and force them, and of course you can't. But then fortunately we have two devices, and then you just take the other one and just set it up a little bit, and then you can do it, and you can just work like that. And because you can dynamically assign what you do, every user develops their own style of working. Which is your dominant hand? Which one do you use to grab objects? Which one do you use to paint on them? How do you do it? Do you paint in free space? Do you project on the surface and paint there? All these things kind of evolve as almost, how do you call it? Emergent behavior, thank you, that's the term. And it's very funny, the moment you create this palette of choices, people start using it and combining it in very inventive ways and coming up with these new ways of using it that you never anticipated.
One of the things you can do in VR that you can't do in the real world too is I can just grab the world and move it in VR. So instead of walking somewhere, for example, I can just grab the world and move it to me. And it's almost like the world is in my hand and I move the whole entire world that way.
If I may, I want to elaborate on that, because that is actually a very funny thing where the VR community and I parted ways a long time ago. The idea that you can pick up the world and move it, which is a bigger no-no because everybody says it breaks presence, but it's so incredibly useful. And you add to that, and if you allow the user to scale the world at the same time, you suddenly get this whole new way of doing things. You can work and you can just take this entire room and scale it down to being this big, and then you build something at rough scale, and you zoom in again, and you build something at coarse scale, and you use two hands for that. And so one of the quickest ways we found to navigate to large spaces is not using a laser pointer and warp or point and fly or have some map in hand, but simply, if I want to go over there, I scale down this entire room until it's this big, then I grab the point I want to go to and zoom back in, and voila, it's right here. So I just warped myself through space in a very natural way that doesn't cause sickness, because you never get the impression of flying, you never get this vection. You just zoom the world and go back in, and you're there. It's amazing, actually, and our people came up with that.
I think the reason you don't get sick is because you are manipulating the world with your hands. Actually.
Absolutely, exactly. Yeah, it's one-to-one.
Right, you're also treating the world as an object, right?
Exactly.
Within a world.
The moment you pick it up, your brain believes it's not the real world. You can move it, and for some reason you would expect to get motion sick, but you don't.
You're stable, but the world's, you pull it towards you instead of pulling yourself.
Yeah, I think that's a great example of the computer bringing its interface to your capabilities and your comfort range.
Yeah, at the very beginning of virtual reality, we are trying to simulate the real world to make everything natural. But the next step is supernatural, is to do something you cannot do in the real world. That's even more challenging and interesting.
I want a portal gun, actually.
Yeah.
We may be working on that.
It's so much fun to have it.
And I know Sixense Make VR, that I'm sure some of you are familiar with, uses a very similar kind of two-handed interface to treat the world as an object.
Yeah, I mean, I think everything these guys just said sort of defines Make VR and why it's so cool, being able to naturally reach out and manipulate objects and scale and size and cut and look at different angles. And
It's very interesting how similar what you guys are doing, where like my understanding was created completely independent, that you kind of came up with a very similar solution.
Yeah, I talked to Paul Murnick about that, and I think we could never figure out if I stole from him or he stole from me, because yeah, I think we pretty much came up with it independently, and I think we are the only ones really. Everybody frowns upon it, but once they try it, everybody loves it. It's just the most natural thing. Can I add one thing about haptics?
Of course.
An observation. We don't do haptics at all, right? But we have this program where you can pick up things and move around, and they have inertia, they have momentum, they behave realistically. And I have a number of people come up to me after I show it to them and ask me, okay, so secret, how do you do the haptics? And I'm like, well, we don't, you know, it's your brain lying to you. The thing is, the moment the interaction is so convincing, the tracking is good enough, the latency is low enough, the accuracy is high enough, that your brain just fills in. If you pick up this object and it is heavy, you feel it. I can't explain how that works, but I'm not a neuroscientist, but it's a very clearly present thing. I mean, it's not just one person who told me that, it's actually a good number of them. And so we don't dabble in haptics because we haven't had the ability to do it. But it's just the sense that it creates and the sense that it comes out of the experience due to presence is pretty amazing from what we've seen in our exploration, and how it really helps in using the software if you have that feeling.
Okay, well, I'd like to open up the floor to questions now, and I'm sure we have all sorts of questions. So if you guys want to come up to the microphone. Go ahead.
Check, check. So obviously we live in the future right now, which you can sort of tell when the real tech has actually surpassed a lot of the hypothetical sci-fi tech and everything. And so this convention's kind of like that. So just kind of going into that, were you guys especially inspired by any, you know, sci-fi movies, books like Ready Player One and Iron Man, stuff like that, in terms of interfaces, and or if not, or even if so, are there any kind of futuristic interfaces and peripherals that you've seen that you still kind of want to achieve?
Over the Minority Report, Tom Cruise tried to do that. That's mimic the 2D interaction, right?
No, sorry. Don't do that.
Hurts
That's so bad.
I agree with you, actually.
Can I say something? There's a tendency, once the technology becomes available, for people to recreate Hollywood interfaces. Don't do it, because they're horrible. They look really good on film, but they're impossible to use. The Minority Report interface being the worst offender. What they showed in the movie looks really cool, but if you do this for more than 5 minutes, you get so sore arms. It's horrible.
Yeah, there's a term for that, gorilla arm.
Exactly. So please don't do that, okay?
Next question?
So I basically, like, a lot of what you guys were talking about was how great our hands are, and how, like, the way we're going to interact with our computers is through our hands. But I wanted you guys to talk a bit more the difference between using your hands and using your fingers, because in the picture of the homunculus, there's, like, the fingers are massive even compared to the palm, and a lot of, like, the devices that we have now, you're grabbing things, you're moving things around, but you aren't really using your hands or your fingers as much as you could. So there's like to me, it's like kind of a difference between a keyboard and a mouse. And a mouse in a lot of ways is really great for certain types of consumption, but to create content, to be able to type, to be able to rapidly, you know, do like QWERTY keystrokes is something that a lot of the input methods haven't really discussed or gone into yet. Like, why do you think that is? What are we doing to make it so that your fingers have as much control as they can? And yeah.
Actually, we are doing like finger interaction and motion capture. Actually, you made a good point that about the mouse, but the mouse and keyboard is not very good for virtual reality, because it reduces the immersiveness of virtual reality, because you're using a mouse, you're using a keyboard, you're not in the virtual world. So the reason why we came up with the hand motion capture is because this is your natural action to get something, to manipulate with something. The most challenging part of this right now is still the accuracy and the robustness, and how to avoid being interfered by the environment, like all those metal chairs and all those signals from your phones, from that TV. So it's very, very challenging. Right now, we are still working very hard and try to make that work. robustness and accuracy. I mean, absolute accuracy for your fingers.
I think it may be because the fingers, you know, are such a large proportion that the bar is almost much higher. And when you look down and you don't see it quite right, or you don't feel things actuate when they do, or when, you know, they go out of field of view and something looks a bit off, that makes them much harder. So I think that might be one reason, is that just the bar is higher.
Yeah, I think one more thing is you are very, very, very familiar with your hand, your own hand. So if there is even a slightly difference between the motion capture and your real action, you will feel it. It's just like when you see a robot without eyes and nose, you won't feel it is not natural. But if you make a very realistic model, you will raise the bar, that raise the expectation. So it's very, very hard for like hand motion capture.
A lot of what you do with your fingers is feel things. So if you're trying to use your fingers in VR and you're not feeling things through your fingers, I don't think they're going to be a very effective device. Actually, when you do hold the controller, I mean, you're using your fingers to do things on the controller. So I think already the fingers are being activated. They're either pressing buttons or they're pulling triggers. So I think that it's...
I'm glad I didn't cuss anyone out.
So I think that if we don't have the feedback in the fingers, like they're saying, I don't think it's nearly as effective as an input device.
Yeah, like really quick, the follow-up about that is like one of the first images was like all the things that we hold with our hands, like forks or apples or whatever. But when you're using a fork, like we talk a lot, like the direct manipulation is mentioned a lot, and we're talking about doing direct manipulation. But when you're using a fork, you're directly manipulating the fork. But the fork is actually the thing that's manipulating the object. So you have some sort of like linked manipulation, but the only way to like actually like touch the thing or like feel what like an apple feels like is not necessarily like the haptic feedback of the weight, but the actual texture of touching it with your fingers. So like, do you think that we really need like full haptic finger tracking gloves, or do you think that like we're gonna have a controller that maybe mimic that or fakes that in a way that, you know, makes us convinced?
Probably going to take us a few steps to get to where you're talking about. I think initially just having hands is really compelling. Looking down, you're like, oh wow. I mean, I think that like almost all the elite
until
motion,
they fall off.
They're all like, wow. You're looking at your hands, and they almost all start the same, you know. And even for just having hands, you look at your hand. But I think it gets really complex when you want to start actually interacting with, like, let's say a physics object. You just want to pick up a ball, and you're going to use your fingers to do that, and have like physics really play nice, and you pick up the ball and it doesn't go squirting out of your hand and flying off into space. It's going to be a much more challenging thing to solve. I think there'll probably be an iterative step where we kind of get there halfway, and you start using your fingers to poke at stuff and flip switches and things. But until you have something that maybe does have haptics and can provide this sense that you're gripping something, or, you know, like if you're going to hold a basketball and you're holding it like this, it's probably going to maybe break the immersion. So I think there's a lot of more challenging things to solve to kind of get to where I think we might get to someday.
From an interaction point of view, I think there's really two things. There's the feeling of the object, where you want to use your fingers individually, because that's how we feel things. But when you actually interact with things, it turns out your hands or your fingers often work in unison. You have the typical pinch motion, and you grab a ball, but you don't really grab one thing with your pinky and one with your thumb. It doesn't work like that. So in many ways, for doing things, tracking the hand is maybe not as bad as it might sound.
As long as you have something like a trigger.
As long as you have something to actuate, exactly, which is why I love those gloves so very much, because you can use your fingers to actuate, but you still use your entire hand for interacting. So in some ways, I think about the way we represent our hands in VR, not graphically, but conceptually, is like my former roommate called it hoof hands, like when you have 5 polygons representing your hand, right, in the old PlayStation games. And that it works surprisingly well. But the other hand, of course, if you want to represent your body in VR, then it needs to be as high fidelity as possible. And so the way I'm treating that, because I don't have access to any of this fancy technology here, is we're using Kinect as a 3D camera to bring your 3D surface into the world. And if you look down, you see your hands, and they are your hands. They're noisy and jaggy and low resolution, but they're obviously yours, and you see your finger wiggle and all that. And because it's not using any tracking, there's no drift, there's no sudden breakup and so forth. And then combining that with the whole hand interaction implemented using a handheld input device or tracking the hands directly, it turns out to be very, very effective. The visual representation that always follows you in this, your brain realizes it's your own body because it always matches, combined with the interaction, it makes a really compelling experience.
I think that watching your video where you showed the keyboard and you're actually grabbing it, like
Yeah.
as a developer, I'm like, man, I wish I could do that. Because everyone's constantly doing this, to try to find stuff. So
It
that
actually
alone
works.
is amazing.
Yeah, check out that video if any of you haven't seen it. It's pretty amazing. Next question.
Hey guys, thanks for coming out. It's a really good panel. Just curious if any of you are familiar or have experienced the work of Will Provencher and his team at Tactical Haptics, and what you guys think of it in the context of the future of haptic feedback.
I've used it quite a bit, and I'm a great fan of it. It's a really good kind of complement to something like rumble or vibration, because if you don't know what it is, it's basically kind of a friction surface that slides against the palm of your hand in the current instantiation, and it makes it feel like something's pulling on your hand, which can give you a false sense of weight or motion happening. And so holding a tool or something and having that friction change can make that tool feel heavy or light, or when you have a throwing motion, you can do it dynamically. It's a very cool input haptic technique.
Yeah. I've been following technical haptics for about, I think, 2.5 years or so, the varying iterations over time as they refine it and change it. And it's funny, when sometimes they hit a sweet spot, and I hope Will is not here and hears that, sometimes they hit a sweet spot where it works really well, the combination of the actuators and the application and the interaction, and you feel it like wow, this is really good. They had this thing where you throw a flail around, and when you throw this flail, it's like, hey, I can feel the flail. And then sometimes they have a setting, a combination of parameters and interaction where it doesn't quite match, and then it's really distracting. So there's a lot of research that needs to go into how do you really map what you want to achieve to the existing handle. If it works really, really well. I love it. And sometimes it doesn't work so well. Then we have to go back to the drawing board and think about, okay, how can we represent this interaction? But in principle, it's a fantastic idea of doing haptic feedback that way.
Yeah, so we work with Will, and I think what he's doing is pretty amazing stuff. And just like he said, some of the demos that he has are really, really compelling. He had this one where you're stretching something, and it was, I mean, it really felt amazing. Some of the fishing stuff, and you're pulling, you feel like a tug. Like there was some really fantastic interactions in there. So yeah, big fan.
What's interesting is the multimodal aspect of it. When you just have the sliders by themselves, you don't get that illusion at all. Like you're not going to be fooled. But when you're seeing the same thing and it's synchronized really well, it's just you really feel like you feel that it's in your hand and that it's actually you're holding that physical object. It's pretty amazing.
Hi. Make VR was mentioned earlier. I think it's a really cool application of VR input. Is there going to be a Kickstarter again? Is there going to be a demo? I want to try it on my Hydra.
So yes, that project isn't dead. We'll definitely announce something soon for it. So, but a lot of that, what makes Make VR is a lot of this talk up here. It's really this really fantastic multi-touch, 3D interface. And you start to get really, really good at manipulating the environment and these objects just because of everything we're talking about over here, just one-to-one. And it's super intuitive. So yes, it'll be coming back. I don't really have a date for you, but yeah, it will be coming back.
In the meantime, you can download my stuff.
You hinted at a great panel. You guys are great. So, you hinted a little bit at non-fatiguing VR interaction with the Minority Report, and I spent a lot of time with the Leap trying to think about this problem. And I'm thinking about how much power we have. There are some good things about the mouse. You can move worlds with a mouse click. So tell me a little bit more about thinking in terms of fatiguing, non-fatiguing, especially for long-term use. Sometimes it gets beyond games.
Actually, I think the fatigue thing is relative. So depending on the experience. If the experience is really, really good, your bar is higher. You can stand there for longer, and you can hold your hand longer. And so it's, in my point of view, it is relative. So even by using the same input device, the same input method, sometimes it's about content. So if I'm like playing Diablo and using my hand to kill some minions, probably I can do it for like 2 hours. But if I'm just holding my hand, rotate a robot, rotate a sphere, which is very boring, I probably only spend like 10 minutes.
Also, depending upon what you're doing, that can actually work. I think the mistake that a lot of us make is that, hey, we've got this new input device, let's replace everything else with that one. And I think what you need to do is like learn what's good about your input device and capitalize on it. So like just even my touch screen on my laptop, I don't really use it all that often, but every now and then I catch myself using it and I didn't think about it. It's because I wanted to touch something. I just reached out and did it and I didn't think about it. And that's an example of how that can be good. But if I took away my keyboard and gave you, the tablet and stuff, and it definitely is not as functional as, at least the things that I need it to do. So I think in the right context, it can be a very compelling interaction.
Each experience is going to have to think about the frequency of the different gestures and how they map to the different modes of an interaction.
A big thing that goes with that is how precise your tracking is and things, because then if you're having to make gross motions all the time, that is fatiguing. But if you can make very subtle motions. Yeah.
Especially if you can hold it down at your hip and just kind of use your wrist and cover a wide range.
And that's a great thing about what we were talking about, the two-handed interface. If you can grab the world and bring it towards you, you can work comfortably in your lap. You don't have, if something's up here, you can just bring it down and work comfortably. I worked with Sixense for a while. We did a little evaluation for Make VR with that interface, and users went 3-4 hours. This wasn't in a head-mounted display, but they went 3 or 4 hours with no complaints of arm fatigue. So it's definitely possible to do it well. With that, we're out of time, unfortunately.
But let me give you an example of long-term use. We had one grad student come up to us who wanted to analyze his data. He had spent 6 months working with his data. I don't want to go into the details. And out of these 6 months of work, he got 50 equations that he needed. Then he came up to visit us and used a 6 degree of freedom direct interaction for 8 hours straight in our cave and got 300 equations out of that. So he was really tired after 8 hours, but he was a happy camper. And the gold medal went to one of our former grad students who over the time of the summer spent 150 hours in the cave analyzing his data. In the end, he was just sitting on a chair and doing it just like you said, like this. I was bringing the world towards him. And he was not complaining either because he wrote a paper that got published in Science, and so he was a happy camper. So yes, it is possible to do it. It depends on the user interface, but if you do it right, you can actually use it for extended periods of time without problems.
You want me to answer this one? Really, please, let me say one thing.
Okay, make it real quick.
Okay, HoloSketch, 20 years, 20 hours a day in full virtual reality with a 100 DPI tracker, 6 degree of freedom. The original ultrasonic with a hand glove, like you said, it causes carpal tunnel. It happened.
I believe you.
And the way to fix it, I know. So, and if you want to talk to somebody who's done 20 hours for years, up to 20 hours for years, please contact me. Thank you.
Yeah, we can discuss afterwards. We do have to move on, but I do want to make one last announcement is we're having a virtual reality, immersive reality contest, augmented reality or virtual reality at SIGGRAPH this year. We're going to have the best of the best. The 3 top submissions will be live on stage, similar to what we have here, of about 2,000 people in the audience. And the audience will actually get to vote for the best of the best. And that deadline, if you're interested in submitting to that, is May 26th, so it's coming up real soon. Come talk to me if you want to know more. I have some information about that. And also, if you want to check out my book, 410 pages of VR goodness here, if you want to take a look. Okay, let's thank our panelists.